In this video, we are going to talk about applications of derivatives. Derivative as a rate measure. If a quantity y depends on and varies with the quantity x, then the rate of change of y with respect to x is denoted by dy by dx. So, for example, the rate of change of pressure, let us take the pressure as P, with respect to the height h is denoted by dp by dh, because here we are involving two variables p and h. P stands for pressure and h stands for height. Similarly, if a rate of change of current I is denoted by di, if the other variable is not given, generally we will take the other variable as the time, that is di by dt. Same way, suppose if I am talking about a rate of change of temperature, and if I denote temperature as theta, then the rate of change of temperature with respect to time is denoted as d theta divided by dt. So remember, if I am talking about rate of change, we need two variables, x, y, I and t, theta and t, and so on. If the second variable is not given, we have to consider the second variable as t, that is with respect to time. To solving problems related to rate of change, we have some conditions. Step number 1, we have to read the problem carefully. Step number 2, if any diagram is possible, we have to draw the diagram. Step number 3, we have to introduce the notation, that is assigning symbols to all quantities that are functions of time. Express the given information and the required rate in terms of the derivatives. Write an equation that relates the various quantities of the problem. If necessary, we have to use the geometry of the situation to eliminate one of the variable by substitution. Step number 6, we have to use chain rule to differentiate both sides of the equation with respect to the time t. Number 7, substitute the given information into the resulting equation what we have achieved and solve for the unknown rate. So before going to problems, you have to remember three important formulas. Formula number 1, area of a circle is given by A is equal to pi r squared, where r denotes the radius of the circle. Volume of a cube, capital V, is equal to a to the power 3, where the letter A denotes the side of a cube. Volume of a sphere, V, is equal to 4 by 3 pi r power 3, or pi r cube. With respect to its radius r, when r equal to 3 centimeter. Okay, so in the previous slide, we have given three formulas. The first formula is area of the circle. We know that area of the circle, capital A, is equal to pi r power 2. So if I differentiate with respect to r, that is if I differentiate both sides with respect to the radius r, A will become dA by dt. So what do you mean by dA by dt? Rate of change of the circle with respect to the radius. So it is denoted by dA by dr. That is equal to, in the right hand side, we have pi r power 2. So pi is a constant. The derivative of r power 2 with respect to r will give you 2r. So I can say dA by dr is equal to 2 pi r. Here this r denotes the radius of the circle. In the question, the radius is given by r equal to 3 centimeter. So let me replace r equal to 3 here. We will get dA by dr equal to 2 pi times 3. So 2 pi times 3 will give you 6 pi centimeter squared. Example number 2. The side of a cube is increasing at a rate of 4 centimeter per second. Find the rate of change of the volume of the cube when its side is 5 centimeter. So first we have to write the equation, which variable is changing with respect to which variable. So here they clearly mention rate of change of volume of the cube when its side is 5 centimeter. So we denoted the side of a cube by the symbol S. We denoted the volume of the cube by the symbol V. And as per the given data, the rate of change of volume with respect volume of the cube when its side is 5 centimeter. That means the side of the cube is getting increased. So we denoted the side of the cube as S. So I can write ds. And as I told you before, if the second quantity is not given, we are always taking the second quantity as the time. So I will take ds by dt. So ds by dt is equal to 4 centimeter per second. This is given in the first step. Okay, the side of a cube is increasing at a rate of 4 centimeter. So that means ds by dt equal to 4 centimeter per second. And also they have given the side equal to 5 centimeter. So let us take s equal to 5. What we have to calculate? We have to calculate the rate of change of the volume of the cube. So that means we need to calculate dV by dt, rate of change of volume with respect to time. So I have to calculate dV by dt. To find dV by dt, we already know that the volume of the cube, capital V, equal to s power 3. So I am going to differentiate this equation both sides with respect to t. So this V will become dV by dt. S power 3. What is S power 3? S denoted the side of the cube. So the derivative of S power 3 will give you 3S power 2. Using chain rule, if I differentiate S with respect to time, we'll get ds by dt. In this equation, I am going to replace the S value. In the question, S value is given as 5. So let me replace S equal to 5. Will give you the final answer as 300 centimeter cube per second. Question number 3. The radius of a circle increases at a rate of 2 meter per second. So what is meaning by this? The meaning of this one is dr by dt. What is dr by dt? The rate of change of radius with respect to the time. Okay, and also they given the radius of the circle is 5 meter, 5 centimeter. So r equal to 5 meter, not centimeter, 5 meter. Okay, what I have to calculate? See the second sentence. Find the rate at which the area of the circle increases. That means we have to calculate dA by dt is how much. So dA by dt means rate of change of area with respect to time. So once again we are using the circle area formula or area of the circle formula. It is given by A equal to pi r squared. Differentiate both sides with respect to t will give you dA by dt equal to 2 times pi r into dr by dt by using chain rule. So in this equation, we have to replace the radius value. So radius is given by 5, and just now we have calculated dr by dt also. So we will change both value. So replace r by 5, replace dr by dt. That will give you the final answer as dA by dt equal to 20 pi meter per second squared. Example number 4. The radius of a sphere decreases. Remember, they say decreases. Decreases means you have to use negative symbol, minus symbol. at a rate of 2 meter per second. Find the rate in which the volume decreases when the radius is 5 meter. So from using the first sentence, I can write dr by dt equal to minus 2 meter per second. So dr by dt means rate of change of radius with respect to time. Since they given the word decrease, I am using minus sign. So minus 2 meter per second. From the second sentence or statement of the given question, we will know that r equal to 5. So the quantity which we are looking is dv by dt. I have to calculate what is dv by dt value. Since they say sphere, we know we have to write the volume of the sphere. Volume of the sphere is given by v equal to 4 by 3 pi r cube. So once again, differentiate this equation, left hand side and right hand side with respect to time. We will get dv by dt is equal to, this 4 by 3 is a constant number, keep as it is. Pi also constant, keep as it is. The derivative of r power 3. The derivative of r power 3 is nothing but 3r power 2. Using chain rule, if I differentiate r with respect to time, will give you dr by dt. So in this equation, we will replace r value by 5, dr by dt value equal to minus 2. If I simplify, I will get minus 200 pi meter cube per second. Since we are looking for volume, you have to write the final answer as meter cube. Question number 5. Once again, we are dealing with the spherical shape or sphere shape. A spherical balloon is being filled with air at the constant rate of 5 centimeter cube per second. How fast is the radius, that is r, increasing when the radius is 5 centimeter? So once again, if you are filling the spherical balloon by air, if the time gets increasing, the volume also will get increase. So we can write dv by dt equal to 5 centimeter cube per second. And from the second line, we know that the radius of the given spherical balloon is 5. So r equal to 5. What we have to find? We have to find how fast the radius is increasing. So that means we have to find dr. Since the second the second variable is not given, as I told you before, we have to take it as time. So dr by dt we have to calculate. To find dr by dt, once again we have to write the volume of the sphere, which is given by v equal to 4 by 3 pi r cube. Then differentiate both sides with respect to t. This v will become dv by dt. In the right hand side, we have to treat 4 by 3 and pi as the constant term. The derivative of r power 3 will give you 3r power 2. If I apply chain rule, I have to differentiate r also with respect to t. That will give you dr by dt. Now we'll replace dv by dt equal to 5. We'll replace the radius r equal to 5. We'll replace dr by, we have to keep dr by dt as it is because we are looking for dr by dt value only. By simplifying this, we'll get 1 over 20 pi. This is the final answer. Dr by dt equal to 1 over 20 pi. We no need to simplify pi value. You can keep it as it is. Or if you want, you can multiply by the pi value. So we are coming to the end of this video. So as usual, I will give you some of the exercise problems for your practice. We will give you answers also. Just go through and attempt these questions. See you in the next video.